All right, I want to go over the process of making a test bend. Whenever you get a new die, or if you're just new to the game, there's a lot to be learned by just making a test bend on a piece of scrap. And I guess the place to start is understanding basically where your bend starts and stops at, because that's kind of critical to all your layout, is where you consider your bend to start at. So this one is a 5-inch die. So what I'm going to do is bend a 90-degree angle in it, and then I'm going to measure from the outside of the tube. But that will tell me to the start of the bend. But that's going to tell me, you can deduct for the thickness of the tube. That will tell me from the center line of the tube to the start of the bend, or from the outside of the tube, depending on what you're trying to hit. You can go off of different measurements, but it gives you a hard point to go off of and a zero reference for your bends. You can also go in here and lay this tube out and put a line across it every inch, and that kind of gives you more of a visual also about what's going on. But for now, I'm just going to show kind of the anatomy of the bend and what's going on in it. For starters, if you're just starting bending, and you probably are if you're watching this video, so I keep a can of, it's an old oil filter with a brush in it, with oil in it. That's what I use to oil I just use motor oil, because I figure that's made for metal on metal, so it should be good for this. But I use that to oil my die, and I spritz it in there, kind of take and work it in there and work it right here, and that lets me put it just where I want it and not have quite as much of a mess. I used to just pour oil all over it, and it just made a mess out of everything. But a little bit of oil goes a long ways, and it's critical to keep your dies lubed up, especially the outside die. That one, the inside die doesn't really matter, but the outside die is pretty important to keep oiled. So first and foremost, your references don't mean anything until your die's snug on the pipe. So, and this is kind of a feel thing. Oh, my cylinder's open. But you got to get it to the point, all the slack's out of it. Still wiggly. Okay, that's pretty snug. And you can kind of, if you have an air over hydraulic, basically I consider it relaxed whenever like the tube's still tight, but the valve's open on the cylinder. If you do it manually, you're going to have to kind of do more of that by feel on your zero, and it's kind of trickier. It's trickier with a manual bender, especially bending like a hoop if you're doing it by yourself, because you can put some pressure on the die with the cylinder, and that'll hold your hoop level while you get everything held, whereas otherwise you're going to have a helper or a jack stand or something like that. Like I've got I got a roller stand that I use from time to time to help support the end if you got a long piece. But the problem is, as the tube comes around, then it's immediately off your stand. So sometimes it's more practical to stick out on that end as the tube's feeding in. You just kind of got to figure out whatever you got to do, but do what you got to do to get it done. But so I'm considering this as zero, a 0 pointer. May not look like it in the video, but that's 0 to me. And there's multiple ways to do this. And depending on what you're doing, I do it different ways. But for starters, I consider the minimum amount of tube. I like to be flush with this. If you come up too close, you kind of run the risk, especially on thinner wall pipe or tube, of collapsing the end as it's bending. So I like to be out about flush with that. But what I'm getting at is you can use that as a reference if you want. So we're going to mark that, because well, I'll explain later, but you can use that as an offset to your bend and use that as a 0 when you lay your tube out. And the second thing you can go off of is the leading edge of the, get in here, inner die, which I can't hardly get in there to mark. It's about right here. I'm gonna have to mark it down here. That's the leading edge of the inner the inner die, and then you can also mark the inner edge of the follower die. Now, that's not where your bend's gonna start, but that's a reference you can see from the outside when you're getting set up. So what you're gonna need to know now is when we get done is the distance from those lines to the actual start of the bend. So this may be a 3-inch, 4-inch offset, but it still works if you want to use it. But more commonly, you're going to use, I generally use the leading edge of the follower die because it's the closest to where the actual bend's going to start. But the inner die, I don't know the names of them, but you could also use it. It's just going to be farther back. But I'm going to go ahead and bend this 90 degrees and make this make sense. I meant to show also this, your pinch bolt on your tube. It's to keep the tube from sliding in the die, and if you tighten it up before you start your bend, it helps hold everything steady, but it seems like as soon as you start your bend and you start to get 5 or 10 degrees in it, it gets loose again, so you need to keep checking it. And ultimately it needs to be pretty snug, but it depends on the tube how tight you can get it without deforming the tube. This is pretty light tube, but it's probably tight enough to hold it. I've got to reset. I can get about 50 degrees out of my bender before I got to go to the next hole. So I just wanted to bring that up to not just snug it up as soon as you start, but you need to go ahead and check it at least one more time before you reposition, because there's a good chance it'll move on you once everything goes loose, and then you'll never get your tube back in the exact same spot, and then you end up with it unreliable. Your zero doesn't mean anything anymore if that tube's not in the exact same spot it was when you zeroed your needle. So double check that, because it'll move and then you'll be off a couple degrees, and then on the next one, if you catch it and then it's right, well, now you got one bend that's off from the other one. So anyways, I'm gonna go ahead and reposition, finish this bend. All right, the next topic on a thing to learn on your test bend is your spring back. Spring back is not a linear thing that I've seen. Some tube it's more linear than others, but I find a lot of times, like on a 15-degree bend, there's less spring back than like a 90-degree bend, or you'll get to a point where it kind of like breaks over and there may be less spring back on a larger bend. But this gives you a ballpark of where to start, I should say. Generally on hot roll, like HREW, it's usually your 3 to 4 degrees. That DOM I was messing with was about 4 to 5, chromoly sometimes 7 or 8. But what this is I've got a square in here, and I'm square at 90 right here. Pointer's on 90, and I'm square. When I release my cylinder, it's going to pull back, and usually that's a pretty good idea where it's going to go, because if it's got much pressure on it, it'll go ahead and push, but sometimes it sticks, so you might help it a little bit, but don't cheat yourself either. But generally it's about 3 degrees. That kind of acts like it's more like 2, but I'm going to go to 93 before I take it out of the die, because I know it's going to spring back some. So I may actually go to 92, and we'll see where it's at. Okay, it looks like 92 would have actually been closer. I'm just slightly overbent. I don't know if I can give a good example here. We're square down that side, and we're coming in just a little bit on this side, half degree or degree. And I think the reason is because this tube's too thin. It's 14 gauge and it's wrinkling. So the 2 degrees was probably accurate. It's not springing back because it's yielding and it's wrinkling. It didn't spring back that extra degree because, like I said, it just isn't. A thicker tube would have probably been about 3 degrees is what I've always found. But so anyways, the next step here, what we're going to do is figure out the start of our bend. And we know it's a 5-inch die, so the tube's 1.5 inches. So 5 3/4 from the outside edge has to be the start of our bend. and that is about a 1/2 inch behind the follower die. Because 5-inch radius die plus half the 1 3/4 tube, or 1.5 inch tube, which would be 3/4 of an inch. So 5 3/4 of an inch, that is officially the start of our bend. I'm gonna go ahead and mark that in just a second. Okay, so for all intents and purposes, that is the start of our bend, that is the end of our bend. That's 5 3/4 of an inch from the outside edge that way. This is 5 3/4 of an inch from the outside edge that way, which means when you lay out your marks, you need to, if you're going to use the leading edge of that die, you need to add about 3/8 of an inch, is what I would call that, from your blueprints or whatever your measurement is, or else you're going to end up with a bend that starts behind your mark, which is going to make your overall distances longer. You'll have to cheat this. So you'll have to move this. If you're going to go off your, like for instance, your follower die, you'll need to shorten your measurement a little bit to offset for that. But the thing is, you can go off the leading edge of anything as long as you know the distance here. So let's say we wanted to go from blue line to blue line. Let me get some chalk. Let's say we had something we need to hit between these two blue lines. Now we know the start of one bend needs to be here. Start of the other bend needs to be here. And there needs to be... So what you would know is that the start of the bends need to be on the outside line. So the leading edge of your follower die would be this line. And that's where you'd make your mark at so you could see it. Or if you wanted to be the leading edge of the inside bend or bending die, it would be about right here. Or if you even wanted to go off of where the pin goes, it would be all the way back here. But that gives you a point of reference, a hard point to give you a known deduction for where your bend's going to start. So it'll take a little bit of experimenting, but there's a lot of information to be gathered from one test bend. And like I said, and you could go around here and mark this as you bend it to get even more kind of information off of it. But for now, this is kind of trying to keep it simple here, but hopefully this helps out.